So in this one, let's take a look at simplifying radical expressions using multiplication and division. And these are binomial radical expressions, like the square root of 10 minus the square root of 2 is a binomial radical expression. So to begin with this example, well, first of all, notice that here within the parentheses there's nothing to be done because the root 10 and the root of 2 are two different things, unlike terms. When I say root 10, I mean the square root of 10. So that means that the 10 under the root symbol on the outside, that whole thing should be really distributed to each term inside the parentheses. So you're going to send that over here, and then you're going to also send that over here, and you end up with the root of 10 times the root of 10 minus the root of 10 times the root of 2. Again, when I say root, I mean a square root. So now, the square root of 10 times the square root of 10 becomes the square root of 100. You can do that, remember, when the indexes are the same. So when you're multiplying two square roots, you can put under one symbol. If we had two cube roots, you could put, for example, that under one root symbol and so on. So remember that, if we have this in two places, okay, the same index right here, where it says 3, and then right here there's another little 3, then you can multiply, put under one symbol. But we don't have cube roots, I want to be clear on that. We have square roots. The same principle applies. So I have the square root of 100 minus, then you can multiply the 10 by the 2, put that under one root symbol, so that gives you 20. Then after that, well, the square root of 100 is a neat number, that's 10. But the square root of 20, that you gotta simplify somehow, so 20 equals 4 times 5. So you want to rewrite the 20 so that you show a perfect square factor like the 4. The 5 is not a perfect square, so you just leave that under the root symbol. So you're gonna have the 10, which is the square root of the 100, minus, and then you're going to write this as 4 times 5. 4, I have 10 minus the square root of 4 times the square root of 5. You distribute the root symbol to each factor individually. After that, you take 10 minus the square root of 4 is 2, and then you multiply by the root of the 5. You leave that because 5 is not a perfect square and it doesn't have any perfect square factors that could be simplified further. So this is the answer, 10 minus 2 times the square root of 5. You can't do anything with that beyond here because the 10 doesn't have a root 5 in it. So for that reason, the 10 and the negative 2 root 5 are basically unlike or different terms. You cannot combine further. You leave it in that form. Alright, so given here, let's see, our choices would be right here. This would be the correct choice. Let me mark that. And it would not be this one right here, even though it's a kind of like step number 2, because step number 2 obviously means you have to simplify a lot more. So that would not be the right choice right here. And the other ones are completely off. Okay, let's move on. Let's do another one that looks a little bit different at first. So it says 1 over the square root of 5. We're going to simplify that as follows. I'm going to write 1 over the square root of 5. By convention, we don't like square roots in the bottoms. There's a historical reason for that too. So I'm going to rationalize. When you do that, you multiply by a form of the number 1. So I'm going to multiply here by the root of 5 over the root of 5. So I end up with the square root of 5. On the bottom, I have the square root of 5 times the square root of 5, which is the square root of 25. And that gives you then the root of 5 is in the top. So that's the square root of 5. And in the bottom, I have the square root of 25, which is 5. So that would be the answer. If you're in my class, the box expects you to input the answer this way. SQRT, that's short for square root. The number within parentheses, slash, and then 5. Okay? SQRT 5 slash 5. Make sure you put the parentheses around the 5 after the SQRT. So that looks as shown. Again, the goal when you do this, in the simple cases, these are simple cases. If you have like 1 over the square root of 3, then you would multiply by the root of 3 over 3. Because you want to usually come out with like a perfect square on the bottom under the root symbol, so you can take the square root properly, as in the following. Well, the 3 times the 3 is 9, and then you end up with the root of 3 over 3 once you take the square root. Okay? Let's move on. And now, let's do one last one that involves rationalizing the denominator, but this time in the denominator here, I need to make sure this doesn't... I have 3 minus the square root of 5, and then 7 in the numerator. So to rationalize the denominator means to get rid of the square root symbol on the bottom, somehow. So here, I'm going to proceed as follows. I will say 7 over 3 minus root 5, and I'm going to multiply by a convenient form of the number 1. That form happens to be this one. 3 plus the square root of 5. and then 3 plus the square root of 5. Let me stop here for a second. Make sure you understand this basic concept. Whatever that symbol is, this is its opposite. If out here, in front of the 3, where I put a negative green, a green negative, if that's negative, then that's also negative. That doesn't change. The one that you change is the one in the middle between them. You have to do that because the goal is to get rid of the radical in the bottom, and you do that by having two opposite signs. So after we use FOIL, terms will cancel. We'll see shortly what I mean. If these signs are not opposite, what I'm about to show you wouldn't work. You would not be able to make the radical in the bottom go away. So here, let me zoom out a tiny amount, erase the little arrows, and again, these were originally positive, so I just want to restore the signs. But I wanted to point that out to be very clear. And also remember that 3 plus the square root of 5 over 3 plus the square root of 5, that's really a form of the number 1. That's the only number you're ever allowed to multiply by in math. A form of the number 1. Okay. Well, if your goal is not to change the underlying value of the expression, let me be clear that. So now let's continue. Notice that here I have a binomial in the top and a binomial in the bottom. So I'm going to first do 7, and I'm going to distribute that into the parenthesis, into the 3, and into this one right here. Okay? I'm going to distribute that in this. I'm going to get the following. 7 times 3 is 21, and then 7 times the square root of 5 becomes plus 7 root 5. 21 plus 7 square root 5. On the bottom, you have the following. This is a whole side step, because you need to do FOIL on it. So you have 3 minus root 5, and then this here is going to be multiplying 3 plus square root 5. So I have the following. 3 times 3 is 9. So I'm foiling here because it's a product of two binomials. So 3 times 3 is 9. Then I'm going to do 3 times the square root of 5. So it's going to give me plus 3 square root 5. Then I'm going to do negative 5 with the root symbol times the 3. That's going to give me minus 3 root 5. When it comes to these, do remember this basic fact as a side note, as a reminder. For example, 3 root 5 is the same as root 5 times 3. It doesn't make any difference how you write it. It means the same thing, has the same value. And then I'm going to do the following. Negative root 5 times positive root 5. That's going to give me negative, I'm going to be very careful here, negative root 5 times positive root 5. I need to simplify that. Take a look. So I bring the 9 down. The terms here cancel because they're of opposite sign. The last portion looks like this now. You have negative root 5 multiplying positive root 5. To work this out correctly, you do 9 minus, because they're both square roots, you can put this under there as the root of 25. So 5 times 5 is 25. I'm being super careful here. It's going to be 9 minus the square root of 25 is 5, and then 9 minus 5 is 4. And that becomes the new denominator. I've shown you a lot of steps. You don't have to include all of them. If you can make it work, make it work. And then this is the answer, 21 plus 7 root 5 over 4. So you put that in the box there. If you are in my class, you have to input this the right way, or it won't work. So you put it parentheses. In the top, you have a binomial. So you have 21 plus 7. You might type SQRT5 / 4. Be careful with the parentheses. Make sure they match. Always in mathematics, right? This one matches this one. And then this blue one over here, right, this blue parentheses matches the blue parentheses on the outside. Everything always in pairs. And that's it. Thanks so much.